In this video, we will show several examples from Section 7.1, Integration by Substitution. Before we start, we'll review the steps for using the integration by substitution to evaluate an indefinite integral. The first step is to choose an inside function. Let's call it W. The second step is to compute dw. dw is equal to w prime x dx. This w prime x is the derivative of w with respect to x. Next step is to rewrite your integral in terms of w and dw. The fourth step is to evaluate this new integral. The last step is to put your answer back in terms of the original function. So now let's look at the first example. Example 1. Find the indefinite integral of s cubed times square root s to the power 4 plus 5 dx. So now let's observe this indefinite integral. So you see the expression under the square root is s to the power 4 plus 5. This function has a derivative 4s cubed, right? So you see there is a factor s cubed in the integrand. So the only thing missing is the factor 4, right? The constant 4. So that's fine, we can fix this problem. So here we try the inside function to be s to the power 4 plus 5. So let w is s to the power 4 plus 5. So then we get dw is 4s cubed dx. So since we want s cubed dx, right? So we divide both sides by 4. So we have 1/4 dw is s cubed dx. So next we rewrite the original integral in terms of w and dw. So have the integral s cubed times square root s to the power 4 plus 5 dx is equal to, so the indefinite integral, then this is the square root, this is w, right? And the s cubed dx, group this 2, it's 1/4 dw. So we have the indefinite integral square root w, then times 1/4 dw. So 1/4 is a constant, so we can put it in front of the integral. So it's 1/4 the indefinite integral square root w dw. This is 1/4 the indefinite integral w to 1/2 dw. So now we need to use the formula, the indefinite integral s to the power n dx. We know this is equal 1 over n plus 1 s to n plus 1 plus a constant c. So if n is not negative 1, this is a formula. So now we apply this formula with n is 1/2. So get 1/4 times 1 over 1/2 plus 1. X to 1/2 plus 1. Sorry, this is not x, it's w. W 1/2 plus 1 plus constant c. And so get 1/4 times 1 over 3 over 2 w 3 over 2 plus constant c. So this is 1/4 times 2 over 3 w 3 over 2 plus c. Then simplify, we get this 1/6 w 3 over 2 plus c. So So the last step is to change the new variable w back to the original variable x. So we know w is s to the power 4 plus 5. So this is equal 1 over 6 s to the power 4 plus 5 to the power 3 over 2 plus constant c. So don't forget to change your new variable back into the original variable, since in the original integral there is no w, right? This w is introduced when we do this example. So now we are done this example. So let's look at example 2. Example 2 is find the integral e cosine theta times sin theta d theta. So first we observe this indefinite integral. So the exponent of the exponential function is cosine theta. When the cosine theta has a derivative negative sin theta, and there is a sin theta in the integrand, so we can let w be cosine theta. So then dw is negative sin theta d theta. So what we want is sin theta d theta, right? So we multiply both sides by negative 1, get negative dw is sin theta d theta. So next we rewrite the original integral in terms of w and dw. So it's e cosine theta sin theta d theta is equal to, this is e cosine theta is w, sin theta d theta is negative dw. So this is equal negative ew plus constant c. So last step, change the variable w back into the original variable. So it's negative e cosine theta plus constant c. Then we finish this example. So these two examples is about using the integration by substitution to evaluate indefinite integral. So next we will show two examples using the integration by substitution to evaluate the definite integrals. There's just one catch. When you write your integral in terms of w, you need to rewrite the limits of integration too. So now let's look at an example. The third example. Find the definite integral from 0 to 2 x e to x squared dx. So let w is x squared, the exponential. So then dw is its derivative is 2x dx. So what we want here is x dx. So we divide both sides by 2, get 1/2 dw is x dx. So next we change the limits of integration. So when x is 0, so the corresponding values for w is 0 squared, this is 0. When x is 2, w is 2 squared, it's 4. So now the original integral 0 to 2 x ex dx is equal to 0 corresponds to w is 0, x is 2 corresponds to w is 4. So x times ex x dx it's 1/2 dw. So it's 1/2 dw. Ex squared is EW. So this is 1/2 EW. W from 0 to 4. So this is 1/2 e to power 4 minus 1/2 e to 0. So this is 1/2 e to 4 minus 1/2. Then we are done. So when we use the substitution to evaluate a definite integral, we don't need to change back to the original variable. So once we have anti-differentiated, we just plug in the limits of integration. So next example. Example 4, evaluate the integral 1 to 3 dx over 5 minus x. So let's do this example. So we let the inside function be 5 minus x, then dw is negative dx. So we have dx is equal to negative dw. So next we find the corresponding limits of integration. When x is 1, w is 5 minus 1 is 4. When x is 3, w is 5 minus 3 is 2. So the original integral 1 to 3 dx over 5 minus x, this is x is 1 is 4, x is 3 is 2. We know dx is negative dw over 5 minus xw. So now we see this new integral, the lower limit 4 is less than the upper limit. The lower limit 4 is greater than the upper limit 2. That's fine, but we still write 4 on the bottom of the limits of integration. This is because x is 1 corresponds to xw is 4. So we anti-differentiated. So we get this is equal to negative ln the absolute value w, then w from 4 to 2. So this is equal to negative ln 2 minus negative ln 4. So this is negative ln 2 plus ln 4. So get this is ln 4 over 2. So it's ln 2. Then we finish this example.